Hello and welcome. Today, we'll be exploring the bulkhead pattern. This is a key application design technique for building resilient cloud applications. The bulkhead pattern enhances fault tolerance in distributed systems. It's inspired by the compartments in a ship's hull. The core idea is to isolate application elements into pools. The goal is to prevent the failure of one element from bringing down the entire system. This isolation ensures that if one part falters, others continue to function. In cloud applications, services interact with multiple consumers. Consumers might rely on several services. This interconnectedness introduces potential failure points. Consider a service experiencing excessive load. This can impact all relying consumers. Consumers making concurrent requests allocate resources for each request. If a service becomes unresponsive, consumer resources might not be released promptly. This can lead to resource exhaustion, like connection pool depletion. The consumer might become unable to communicate with other healthy services. A service can be overwhelmed by requests from a single client, exhausting resources. The bulkhead pattern addresses these challenges through partitioning. The core idea is to compartmentalize resources and isolate potential failure points. Service-level bulkheads partition service instances based on consumer load. By dedicating instances to consumers, failures are limited to those consumers. For example, a service might have pools for high priority and standard clients. If the standard client pool fails, high-priority clients remain unaffected. Consumers can partition resources when interacting with multiple services. Allocate a separate connection pool for each service. Failure only affects one pool. Other techniques include processes, thread pools, and semaphores. Libraries like Resilience 4J and Poly help implement consumer bulkheads. The bulkhead pattern isolates consumers and services from cascading failures. It preserves partial functionality during failures, maintaining a better user experience. It enables differentiated quality of service. High-priority consumers can use higher capacity or more resilient service instances. Partitions should be defined based on business and technical requirements. In DDD, partition boundaries should align with bounded contexts. Consider the level of isolation and overhead. Options include VMs, containers, or processes. Containers often offer a good balance. Message queues can serve as bulkheads. The bulkhead pattern can be combined with retry, circuit breaker, and throttling patterns. Determine the appropriate level of granularity for bulkheads. Monitor the performance and SLAs of each partition. The bulkhead pattern is useful for isolating resources for backend service consumption. It's also useful for separating critical and standard consumers. The pattern prevents cascading failures. However, it might not be suitable when resource efficiency is paramount. In conclusion, the bulkhead pattern is a powerful tool for building resilient cloud applications. It minimizes cascading failures and maintains functionality during outages. Careful consideration is needed for partition boundaries and technology choices. The benefits make it a cornerstone of modern cloud application design. Thank you.